Good evening. My name is Venkat Malladi, Senior Scientist at Microsoft Genomics. I unfortunately couldn't be there with you in person this year, but hopefully everyone's enjoying the summit, and I look forward to joining you guys next year. I'm going to walk us through what Microsoft and Azure have been doing in Nextflow with a little bit of deep dive and how we like to think about where we're going to be empowering the next decade of life science innovation and transformation. So when we think about data analysis ecosystem on Azure, we don't think of it just as genomics. We really are thinking it as a full stack development suite, right? Where we have everything is layered on our high performance infrastructure, but we can think of this as our open data, control data, orchestration, scheduling of jobs that really get used by Nextflow and other workflow managers, and then think about this as how do we optimize all of those runtimes to service the scientists, right? We want to, as other people have said, reduce the time needed to deploy these tools and increase the amount of time we can actually do the interesting science that we want to actually innovate on. So, as we said, we think of this as a couple steps, right? Data management, repositories, and high performance infrastructure, right? At the base level, behind the scenes, we're using all the cloud-based architectures with virtual machines, Azure Batch, Kubernetes, things like that, and for our cloud infrastructure. And then on top of that, we're thinking about the database solutions where we have Azure Data Factory, Cosmos DB, the Explorers, Azure Synapse to explore data and store it for fast retrieval. In addition, we're thinking about how to integrate all of this data, right, with health data APIs, Azure Purview, which is our unified data model, and Genomics data lake. Sitting on top of this data management and high performance infrastructure really is how do we do managed cloud services? We're thinking of Azure Batch or Azure Kubernetes. How are we doing distributed compute with HPC schedulers? We have Cycle Cloud, which you can really spin up your own HPC and do load balancing, dynamic load balancing, and really do a Slurm, cluster, grid engine, PPS. And then on top of that, we can do Nextflow, which can submit to Cycle Cloud, can also submit to Azure Batch and Kubernetes. Lastly, we're thinking about our applications and services and data analysis tools, right? And so we're looking at cloud-native services like Synapse, machine learning, but really turnkey proprietary applications, right? Illumina, whoever wants to develop these things, how do they live on top and talk to the ecosystem that workflow managers and take advantage of our high-performance infrastructure. In addition, we have all these other open source tools for data analysis, for secondary and tertiary analysis, right? Jupyter Notebooks, RStudio, Bioconductor. We'll kind of go a little deeper in this, but we really think of this as a whole ecosystem that can empower your research. You should be able to deploy all of these pretty easily and use it as a grab bag of what pieces you want to put together to facilitate the research that you guys need to do. So let's talk about some resources in Azure. One of the biggest resources that we have are public datasets on Azure, and this is predominantly, I want to highlight, our Genomics data lake on Azure, which has lots of commonly used genomic datasets. We have Azure Notebooks implementation for easy data access and analysis. It's easily integrated with genomic workflows, and you only pay for the Azure services consumed while using the datasets. Highlighting here are some of the genomics datasets. However, really our open datasets encompasses a large amount of data. We have environmental data, energy data, geospatial data, imaging data, right? So think of this as we grow, this is only growing as we currently had 1 petabyte, it's only growing larger. Additionally, we've been working with Phil and the RefGenie team to actually use RefGenie and have that also live on Azure. And so you can usually have reference database references and their indexes for different tools already pre-built into Azure, and you don't have to actually reutilize them, or you can just utilize some of them and move them to your own subscription. Additionally, we have Bioconductor team that has worked on Azure. So we have all the Docker containers for Bioconductor and their deployments that work are built on Azure and deployed through the Azure Container Registry, official Microsoft Container Registry. This allows for a couple different things. You can do some pre-building testing of these Bioconductor packages in Azure, but also integrate these containers automatically into your Nextflow workflow. So if you wanted to test it, we can talk about looking at the Azure container instances, really just stand up a simple instance of whatever tool you want to do a quick analysis, and tear it all down without having to spin up a whole VM environment for it. But the biggest thing that we faced, as I've been on both the Microsoft side and previously on the academic medical side, is how do you deal with a lot of this development and testing of these workflows and scalability and have other people contribute really readily. So how do we integrate GitHub and Nextflow, as most people are doing this in GitHub as an example? So one of the challenges we wanted to address is how do we quickly develop, test, commit changes into a suitable virtual environment for all our developers. And so our solution that GitHub came up with was GitHub Code Spaces. This is a development environment hosted in the cloud. It's customizable for each project with various configuration files. It runs on a variety of VMs, sizes from 2 to 32 core machines, and you have 2 options to connect. You can either connect it through a browser or a VS Code desktop. What this allows us to do, really, and we've showed this as an example in one of our recent blogs this year, is we've set up a demo Git repository for Hello World, and it already has Nextflow already built into it. So if you go into that GitHub repository, you can say code, and instead of doing a Git clone, you have code spaces, and you can create a code spaces from the main branch or any branch that you want to do. Then once you hit this code spaces, what pops up is an entire Azure virtual machine with a Docker container, and in it we already have a pre-built that Nextflow is already running in here. You have your Git checkout of that repository right here, and you have VS Code. And so you can really do local testing. This ensures that you can also start doing your development and changing files and do commits. We've also tested this as a way for you to launch these pipelines to other services. So if you have a config in here that you want to utilize and test in Azure or some other local service, you could totally do this all within this web browser and Explorer. What we can do going forward is Nextflow is only part of it. What we could do is you can add Nextflow, you can add the NF Core already into it here, and so for every NF Core template project, we can already do the development within effectively GitHub and never have to really leave that environment. So if you wanted to do a quick checkout, you need to check out a branch or PR and do some testing or some modifications, you really have this full dev environment for yourself. Additionally, what we're looking at is community outreach and support. As Phil announced earlier, Azure and Microsoft are supporting NF Core team to be able to run and test all the NF Core pipelines in running their CI/CD on Azure. This will allow us to fully test what we've been doing manually for the last couple of months. All the pipelines to be cloud ready. We're actively testing and development of these pipelines, and we're very active on the Slack channel and answering questions all the time. In the general Nextflow community, we're also active on the Slack channel and the platform Azure, so any questions you can easily relay, and someone on our team will be answering or looking into it or working with the Nextflow community to understand what the issues are with specifically Azure. We're also actively testing new features as we develop them in Azure Batch or Kubernetes and suggesting new features to the development team. So how do you start deploying your pipeline? I was going to make this talk a little bit more deep dive into how Nextflow will be deploying on Azure. However, actually recently with Sakara, there was a blog post that you can check out that's Nextflow and Azure Batch. Kindly, I took this picture from them. But effectively, you can have a head node VM in Azure that has Nextflow and config. Additionally, you can actually deploy this whole thing using code spaces as your head node, as long as you set up in your Azure Cloud a batch service, which has all the compute pools, your Azure storage account with all the data that's shared there, and an image registry like Docker Hub or the Azure Container Registry. For the most part, this works really well and gets everyone off the ground. The biggest sticking point for most people that we've seen is this head node VM. Either they're running on their laptop, or they don't really necessarily want to set up a huge node on Azure necessary to run this and maintain this connection. So one of our teams of CSAs have come up with another potential solution that we did a proof of concept to explore. This is Nextflow with a Blazor Frontend. And so one of this was our goals to demonstrate hosting Nextflow on Azure. We wanted to provide a web interface, a simple web interface to execute pipelines and test it that can be easily deployed in your subscription. We wanted to leverage PaaS where possible, and we wanted to reduce the virtual machine dependencies. And so this architecture is all available. We have a blog about it, as well as an open Git repo that you can go in and actively fork and continue to deploy. The idea is that we have this Blazor web app front end that runs as our Nextflow runner UI. We have a SQL database that stores all your runs and information about which pipelines can be run. We have a web API and orchestrator using Azure Functions. That's a serverless runner that's going to then spin up Azure container instances for every head node that is needed. And the container instance will run Nextflow with native Nextflow commands and submit all of that to your batch account to provide all the information with inputs from Azure Blob Storage. We have a weblog that have an Azure function that's relaying this information when this container instance is in the status. That gets provided back to our web API, and you can actively see whenever where the status of your job is. So if you look a little bit, the Nextflow with Blazor Frontend, we have a simple UI. No means compares to Tower, but it's just an example of what people could potentially build on top and extend out. You have available pipelines. We have the Nextflow IO Hello World, and we took the NF Core AttackSeek pipeline. And you can really see run statuses of these pipelines. When they were recently run, what are their statuses if there was any issues, and when the last status update was. When you hit the execute, right now we have it kind of hard-coded, and really as an example, if you actually go into our blog post, this is a publicly available site. You can really run the attack seek as an example as long as you provide it your own batch name, batch key, storage name, and Azure location of where your storage is, and the SAS token. You can actually run this example in your subscription with this front end. So this is also a good way for us to help customers do a POC where they wanted to just test Nextflow. Maybe they don't have the capabilities of running everything in Azure, and so we can easily quickly get them set up with, maybe they already have a batch account and a storage account from IT, and they could just go in here and run this NF Core attack seek test full run and see what that looks like and look at what the cost is. Once you execute the pipeline, we can look at the job statuses. We have previous runs, what the run name, what you call it on, when it was started, and what the status is. So this is really good to start with how to test pipelines and how to deploy pipelines on Azure. But one of the biggest issues I knew I faced as a developer of pipelines is optimizing our pipeline resources. We might think we know, but they might be dependent upon each cloud, and we might want to optimize it better for different types of architectures and different types of workloads, and maybe we need to optimize it for different resources or time constraints. So we embarked on how do we tackle this problem as an optimal compute choice. So we wanted to make, our objective was to make an optimal choice of compute resources and look at some of these trade-offs between cost and time. We want to run as fast as possible. Do we run it as cheap as possible? Can we run it as fast as possible but do not spend more than $C per each sample? And can we run it as cheap as possible but do not spend more than T hours per sample? Our solution was to iterate on various configuration files, and Nextflow has made this really easy for us. We can then have, on any given pipeline, really provide multiple different configurations and provide with a sufficient large number of representative samples to collect enough data to then start suggesting what the optimal compute choice is based on your representative set of data samples. I think key here is you really need a representative set of data samples. You can't necessarily start with the lowest amount of sequencing depth. You really want a representative sample of what you're getting. We think you're probably going to get over the course of your project. And really, the point is it's not just a one-time snapshot, is as you're collecting all this information, we can store this information in a database from all the telemetry, and really you can be constantly updating these configs based on the newer data sets, and that's the goal. So we started off with two pipelines that we're working on, the NF Core RNA-seq and then of course Seric pipeline. We start with the pipeline DAGs, so really you start with the basic infrastructure without running the pipeline and we take that DAG input into our algorithm. We read in task compute requirements to generate an array of potential VM sizes based on what the suggested starting minimum requirements are, and then we can start tweaking from there. Our outputs read in Nextflow telemetry to compute cost, time per task, and overall workflow for optimization. And then we have a suggested optimal VM config based on users' input on the cost versus time scale. So one of the things this looks like we took advantage of, we could optimize per every step, but we thought also, could we just use what's already in NF Core, which was they had all these labels with process low, medium, high, and high memory. And so we kind of took that as a first process with this, as making it an easy low bar. If we just started with that, how accurate would we be able to start gauging the compute requirements based on just those low, medium, and high requirements? And so we provided a default queue, this DD2V4, and then we provided the other VMs that we thought based on the requirements of the high memory and medium memory labels. So let's talk a little about our preliminary results. For the NF Core RNA-seq, we used our ENCODE data, which is part of our open dataset model. But we took representatives. We took one lab's experiment with 55 samples and looked at representative samples on the quartile of that experiment. This is just a start. We limited ourselves first by just one family of configs of VMs, so the DDV4s or the EDV4s, slightly different base architecture, and we ran them. And if we looked at cost of running this on dedicated nodes, we're looking at the DDV4 was around $4.50 per sample, and the EDV4s was $2.88. The duration for both of these was fairly similar. We're looking close to 2-hour mark on running per sample. If we switch all the way down to a low cost priority nodes, we can get all the way down to about 60 cents for the EDV4s. So the time really wasn't a constraint for the RNA-seq. However, we could optimize really well for this low priority nodes. And this is the config that we ended up with for the preliminary config for the RNA-seq for Azure. We're looking to add these configs over the next couple of months into the NF Core's pipeline-specific configs, so that starting off in Azure, you'll already have a base config that you can start playing around with. Our future direction is to test more representative data. Since we have a lot of the ENCODE data, but we have a lot of other publicly available data, we wanted to run through a larger mix of samples. For the SARIC pipeline, we've also started to do a mix of families and not stick it to one family type, just to see what other cost benefits do we get. We want to provide these default pipeline configurations for the NF Core pipelines for optimized for a cost and maybe optimized for time. And so we might have at least two configs in the future that are optimizing for all of these pipelines in NF Core. And then we want to expand the algorithm to look at mixed family types, like I said, and also make this open source in the future. So then as you develop your pipelines, your individual pipelines, you're going to be able to effectively take all the telemetry data and start scaling your compute requirements accordingly. And this should help with budgeting in the future for a project, grant proposals, and things like that as well. I want to say thank you. It's been a pleasure speaking to you and virtually meeting a lot of you on the Slack channel. I'm happy to take any questions now on Slack, and hopefully I'll be able to answer those. And looking forward to continuing interacting with many of you in the community in the future. Thank you.
Excellent. Thank you very much for your talk. That was, I don't know where to look. that was really interesting. It was really good, and a real deep dive with deep technical knowledge on Nextflow and NF Core there, which is really interesting to hear. And thank you again for supporting NF Core with these automated tests. I'm really excited to see where we can take that. I've got a couple of questions from the audience for you. Matthias asks, do the GitHub code spaces on the NF Core repos also come with the NF Core tools pre-installed?
Yeah, we can make the config to add that too. That's, I think, our goal is we can make all the make that as default. There's an easy way to add this as the configs. Just putting base Nextflow was our first example. I think we can also add Tower CLI in the future as well. To allow, we can have Nextflow, Nextflow Core, and Tower CLI.
Paolo asks, are the front end and the opt service already accessible?
Yes. Yeah. We have, they're already available.
I can see Harshil's writing a question. Is he going to post it in time? All right, I'm going to give up. Maybe we can take that one to Slack afterwards. Harshil's fingers aren't quite fast enough. Thank you again for an excellent talk, and hopefully we'll see you in person next time.
Will do. Thank you. Bye.